We're here to talk about habitat at enterprise scale. We're going to introduce ourselves in a minute, but well, let's just go to that slide.
Oh, that is awfully pixelated.
Yeah. So funny story. This year they made us put all of our slide decks into like a Google Drive, and then they transferred our Google Slides into PowerPoints. So I have not seen this deck since they took it from me. So it's going to get real interesting here in the next 30 minutes or so. But hey, I'm Andrew Dufour. I'm a lead customer architect at Chef. I've been at Chef for about 4 years, just closing in on 4 years now. This is my second time speaking at ChefConf. And
I'm Josh Hudson. I started a couple months after Andrew, so about 3.5 years. I'm the lead customer engineer for our strategic customer engineering team. And this is my witness protection photo, apparently.
Very pixelated. Yeah, blurred for sure.
Cool. Let's get started.
Yeah, so really what we want you to be able to get out of this talk is to learn some of the experiences we had over the last year and a half deploying Habitat out into production environments at enterprises. So there are some assumptions I'm going to make about your base level knowledge. You're in the right room here if you have a working knowledge of Habitat. You don't have to be a master, but when I say something like Supervisor Ring, it might not be the right room for you if you don't understand what that is, because I'm not going to go in depth and start at ground zero and say like, hey, this is a Supervisor Ring and how it works and all these things. I'm going to assume that you have at least some level of knowledge of that. You're also interested in things that we've learned deploying Habitat in enterprises. I'd love it if everyone can bring some thoughtful, insightful questions. And there's a couple slides in here where there's not a lot of content, and I'm going to ask you some questions and just see what people think and what solutions people think of. So, if you want to be part of a discussion and involved in that, that'd be great as well. So,
or if you just don't like awkward silences.
Yeah, because I will. Something that Agile coaching taught me is let the awkward silence happen. So I will let it happen. Just an overview of what we're going to talk about. Installing and managing Habitat, monitoring your Habitat supervisors, application deployment models with Habitat, compliance and configuration management via Habitat. We're not going to get super into that, but we'll at least touch on it a little bit. Change and release management, security, and then Josh is going to follow up the end of the talk with some scale discussion. So let's talk a little bit about installing and managing Habitat. So something that we learned very quickly is that configuration management is still a thing. Even if it's a very small sliver of configuration management that goes and installs Habitat on your system and tells it which packages to run and how to configure those packages, you still need something up front that does that. In a couple cases, we've had people create custom scripts, like a PowerShell script or a Bash script. I will count that as configuration management. You're taking the input into like a flavor of a machine, and you're going and configuring what you want on that end system based on that. You still need something there to do that. There's also some security considerations, like if you want to be able to change a security key on the box, and that exists before Habitat starts. How in the world do you change that if you don't have something there to actually manage that configuration? So configuration management is still a thing. Create your supervisors with auto update on and point it at a specific channel. So Habitat does channel-based software delivery. The Habitat supervisor is able to update itself based on a channel subscription. So what we're saying here is that you should subscribe your Habitat supervisors to channels and allow them to auto update when you promote Habitat supervisors into that channel. So if you don't want to have a big bang in production, you can separate production out into like a 1%, 10%, 80% kind of channel hierarchy. But you do want to make it so that Habitat is able to update itself. And the biggest thing here is we don't want to let Habitat become part of your technical debt, right? Suddenly you've automated all your applications with Habitat. You're delivering all these applications continuously. But every time you got to go do a Habitat supervisor update, you're logging on to 5,000 systems and just hating your life, right? You don't want to live like that. So plan ahead, plan for these auto update strategies, and you should also be pipelining and automating the release of new Habitat supervisors. So you should have a Jenkins or a Concourse pipeline, just like you have for anything else, to actually go and release those Habitat supervisors into your environment. And that's both for stability and for release management.
Anybody that's on Chef 11, you know what we're talking about.
Exactly. You don't want to have to deal with another Chef Client Updater, right? Right? Anyone done a Chef Client Update with Chef Client Updater? Yeah, you know what I'm talking about. I'm going to stop there. Any questions? All right. I've got some questions for you. So Chef in general has really focused around and doing infrastructure as code and following infrastructure as code practices has really followed along these local development practices. We realized that, hey, we've suddenly put all of our infrastructure in code. How do we test it? We have the same kind of challenges with Habitat. So, Habitat being a Docker-based development studio, can anyone tell me a challenge you might see in an enterprise trying to use the Habitat studio inside your enterprise? Sorry? Proxies?
Boxes.
Boxes? Okay. Yep. People just, sorry? Yeah, Docker on Windows doesn't always get along. True. There's one at the back there.
Elevated privileges.
Yep, limited privileges, all these things, for sure. Any other ones? Some of the people up at the front from unnamed organizations. Would you like to throw in a couple?
We're using VirtualBox, and it's mutually exclusive with Docker.
That's a great one. So VirtualBox is installed on a machine because you've already set up your test kitchen infrastructure, and you're ready to go. And people have been developing chef recipes, and VirtualBox and Docker sometimes don't play nice together. There are some ways to make it happen now, but actually when we started this, there wasn't. So basically, you had to pick: do you want Docker or do you want VirtualBox installed? So now, how do you develop your cookbook, and how do you develop your Habitat plan at the same time? It became quite a little challenge, I would say. Anyway, can anyone think of solutions for that? How they would work around some of those things? Use the cloud, to the cloud. Yeah, I mean, you can. AWS instances. Have like an AWS dev box that you can install Docker on or something.
No, I meant like a test kitchen, point at AWS, don't use VirtualBox.
Yeah, okay. Cool. Anything else?
You want to just use Docker and use kitchen docking for your chef test.
Yeah, and then suddenly you're using Docker images to test your cookbooks instead. So the answer there was use kitchen Dockin instead of kitchen VirtualBox. That would also work. So you would use Docker containers to pick that up and test your cookbooks instead of using VirtualBox machines. And the other thing that we did was we created basically a set of cookbooks that has a kitchen YAML file in it, and it synced a HAB directory from the cookbook directory. And basically, you would launch a VirtualBox machine. Inside it, you would have Docker installed, and then you basically had a little development environment to work on inside of that VirtualBox VM. So a lot of different solutions. You could do the same thing with AWS instead of VirtualBox. You could do the same thing with Azure. So lots of different solutions, but at the end of the day, the reason there's no definitive solution here is because it's going to depend on your company, your environment, depending on your restrictions and what you need to do there.
And just to add on to that, the nice thing about developing in the studio is because it's a clean room, whether that's on your local workstation, whether that's in a cloud workstation, whether that's on your workstation, in a VM, in a Docker container, it's the same clean room anywhere. So you end up with the same artifacts with the same intended dependency graph.
Exactly. So talking a little bit about monitoring your Habitat supervisors. So I would always advocate that you use your enterprise's standard monitoring agent to capture metrics that you need. Some of those are CPU, memory, disk I/O, things like that. One thing that we found out really quickly is that when Habitat is a thing that's launching 10 applications, and someone starts Habitat, and suddenly there's like 50% CPU utilization on your system, people blame Habitat, right? So it could be one of those 10 applications that was launched as part of Habitat, or it could be Habitat itself. But you need the granularity to be able to tell that. So break out the monitoring so you know how much CPU, memory, disk I/O the Habitat supervisor is using versus how much the applications it's launching actually use. It just gives you that visibility to either come to Chef support and say, hey, you guys suck, or it gives you the visibility to go back to your application owners and say, you need to work on this, or your application is really consuming a lot of resources, or maybe that's the way it's supposed to be. I've got this Habitat Prometheus exporter that I've been working on. It's kind of code smell right now, not going to lie. It's very MVP, but what it can do is it actually monitors the supervisor endpoint, pulls out the health checks of each of the packages that are deployed, and then actually you can send that to Prometheus and show a graph and show each of the packages installed on a system and what the current health status is of that package. So it's just a cool way to be able to inventory and keep track of what's there and what's passing and what's not.
And because it's implemented in Ruby, it's very easy just to look at it and see all the endpoints that we're leveraging, and just get some learning out of it, even if it's just something that you want to look at for educational.
Exactly. Yeah, it shows you how you can parse all that, all the endpoints that are there in the Habitat supervisor as well. We're going to talk briefly about the application deployment models we've been seeing, and go over these. So the main one that we've been seeing is physical and VM-based deployments so far. And really the gist of this is that you don't know how long your infrastructure is going to run for. So physical is likely long-lived. VM can be on any span of that. And on both those cases, your company is going to have a set of base packages that it wants to have installed. And these things are going to be like backup agents, antivirus agents, things like that are kind of like the barrier to entry to you being able to go and launch a machine inside of your data center or inside your cloud account or something like that. When those things are provisioned, they usually get provisioned based on some sort of flavor. So you might have like an MS SQL cluster, or you might have a single machine that gets launched that someone's going to pick up and use after. But that thing is based on some sort of provisioning code or catalog option. There will be some customizations that get passed into the machine after. And hopefully that showed up well. It did. All right, so this is kind of like the flow that we've been seeing people do. So user chooses a machine type or a set of machines to build. The infrastructure layer builds. That could be Amazon, that could be VRA, that could be whatever is building your infrastructure for you. There's some sort of lightweight configuration management script that picks that up and takes the information you need and passes it through, installs Habitat, launches the packages you need, configures the Habitat ring as it needs to be configured, actually launches those packages, and then you've successfully built a machine at that point. Just talking a little bit about our ideal stack at this point, and for provisioning, you'd see something like Terraform, CloudFormation, ARM templates, or if you're looking at bare metal, usually if you want to provision bare metal as code, you're stuck using whatever your hardware vendor gives you, so HPE, Synergy, Composer, whatever the IBM equivalent of that is, that kind of thing. You've got some sort of lightweight Chef or configuration management instance that's helping with the bootstrapping process. You've got Chef installed via Habitat and Inspect via Habitat to do config management and compliance. And then on top of all of that, you have your applications and services, which I'll just call applications from now on, running via Habitat itself. For container-based deployments, I'm going to say that most of our deployments so far have been based in the VM and the physical space. For a lot of enterprises that have been looking to use this, containers are still a little bit immature. How many people in here have a production Kubernetes cluster that's running and actually running a service that a user uses? Nice. Wow, it's getting better. Every like 6 months that goes up. Who has something that's like more than 10% of their workload goes through that Kubernetes cluster? Yeah, okay. So still like 90% skewed towards VMs and hardware. So really, like what we'd advocate is we're not going to change the world on you in the container space right now. What we would say is create a standard container release process for your org, export your apps and packages to containers, and ship all your containers the same way. So however you're shipping your existing Kubernetes services, I wouldn't drastically change that. I would keep shipping them the same way. Habitat gives you an easier way to take some of those things that you're building for VMs, pick them up, and move them into containers, but that's a whole other talk. So I'm not going to get into it right now. We're going to get into supervisor rings now. So we have solo supervisors, we have environment-based supervisor setups, we have service-based setups, application rings, and what I'm call persistent data service rings, and we'll talk about each of those and what they are as we go by. So solo supervisors is kind of your simplest topology and deployment. Should be your default choice when you can. This is when you don't need any of the ring features, but all the scaling considerations here are on the builder service. So it's ideal for deployments that are mainly things like agents or individual web servers or things like that you don't need communication within the ring to talk to other instances. It's also ideal if you're using other tools for service discovery. So say you're packaging up and deploying your application using Habitat, but you have a console service, or you're using Kubernetes and some Kubernetes native service discovery. You wouldn't necessarily need to join a ring to get the Habitat service discovery features. So you would instead just deploy these as individual supervisors, and basically they would be in there on their own and not talking to each other. The next one, and this is what I was worried about. All right, I guess it's fine. So
Supervis or
supervis
service.
or and service. All right, perfect. This is definitely what I was worried about when they took my slides and made them PowerPoints. But when you have an environment-based setup, basically we're looking at, hey, you automatically join an environment that matches dev, QA, prod. You likely have environments that are named like that. There is a cost to scaling in this case, and depending on how big those environments will be, Josh is going to get into maximum ring sizes and stuff like that as the presentation goes on. Just know that the bigger you make the ring, the higher the cost to the supervisor and in a memory, CPU, and disk perspective. And the nice thing about this is it simplifies joining of the ring. So say you don't have full automation on secrets management and stuff like that. One of the things you need when you create a new ring is to create a new encryption key. So that ring will then have all of its communication encrypted from that point forward. And if you don't have an automation process to go create a new key, put it into Vault, and then pull it out of Vault and all your other systems, it can be a bit of a challenge to create dynamic rings. So in this case, we would create like a dev, a QA, and a prod ring to simplify things. And anything that belongs in dev, you would provision into the dev ring. Anything that belongs in QA would go there. This is a good pattern when the details of a system's vertical isn't known. So like, you've got a web team, an app team, and a database team, and never shall their paths cross. And they're kind of all setting up their things all on their own. That never happens, right? But when they don't really know how each other's things are going to work, and they need to be able to bind to everything else in dev, that's when this environment will make sense. The next one we've seen is service-based setup. So in this case, you'd have like the same setup as before, but we're going to narrow it down to a service. So let's say all your MS SQL services, you don't really care about them being in their own rings, but they need to be able to communicate with each other because they have to join together. So in this case, it would be dev or QA or prod for MS SQL. Joining the correct ring would be handled by that provisioning as code system. Scale will have a cost again because you're not limiting this to a finite number of systems. It's going to keep growing. And you want to, something that I haven't been calling out, but you do want to separate service environments for security considerations. So from dev to QA to prod, you will want to have separate rings and separate wire encryption keys for security reasons, and we'll go over that a little bit in a couple slides. The second last one is application rings. An entire application stack sits inside of a ring. You need to be able to provision a ring dynamically in this case. So you have to be able to create a new encryption key, store it in Vault, pull it down from the other supervisors, have those supervisors join the ring, all that kind of stuff. This is ideal if you understand an entire vertical of an application. So if your team is a DevOps team that has an entire application you run, or your site reliability engineers that actually has a specific app you run, this is great for you because you have your web app, your web, your app, and your database tiers all together. Again, I'm going to say you still want to separate those rings based on environment for security reasons. The last one I'll talk about is persistent data services. So this is where you have something like a highly available MySQL or PostgreSQL cluster, and you want to create these tiny rings that just have the members of those clusters in them, and they kind of dynamically configure and are able to do leader election and things like that, and become a highly available data source really quickly. This is a really sweet spot for Habitat, just because of the leader-follower election that happens, and it makes it super easy to stand up a highly available database or highly available data service really quickly. Another pattern we've been seeing is people running infrastructure in Kubernetes or in Mesos, basically using an open service broker API to get a data service. A lot of companies aren't running those persistent data services in containers, so they'll have PCF, call an open service broker API, stand up a MS SQL database or a PostgreSQL database, and then they'll consume that from the application side. And the big deal about that is, in a lot of places, you're still submitting tickets for your databases. So we've seen a huge amount of ROI on those things. I'm not going to get into this a whole lot. This is basically Effortless Pattern that you've been seeing the last couple days, and I'm running a little long. So just talking about treating every single thing that runs on your system as an application, packaging in Habitat, and using it in that method. So we're really talking about the Effortless Pattern here. Right now we're talking about Chef and Inspect with that. You could potentially do the same thing with other configuration management tools. There'd be nothing stopping you as long as they have a method of kind of packaging up and running their configuration locally. For change and release management, the strategy we've been using is using channels heavily. Pipelines are king here, as always, in DevOps tool chains. And don't get lost in the sea of red tape. So there's a ton of red tape that comes with change and release management. You kind of have to pick your battles a little bit because enterprises do have this very rigid, stick to ITIL, stick to change management kind of philosophies. So you're not going to win this battle in a night or a week, but you need to continue and have applied pressure on this over time. And remember, there are things in ITIL that actually bring it into sort of the continuous delivery, continuous integration, DevOps age that make it possible to start running at velocity, even adhering to an ITIL philosophy. Just at a high level, these slides will be available after. This is kind of like just a jury-rigged together release process. So a change should always be kicked off by a commit to the Habitat application repo. A build server should pick that up and build it. Based on a success inside of that job, you should be doing things like lint and unit and syntax checking. You should be building like a little one-machine environment to test that out. Based on a success or failure of that, you should be going to provision an acceptance environment, and a release or a change manager should be looking at that acceptance environment and either approving or denying it. Based on that approval, you should release to the next environment. I put production there, but it should be, next environment. Maybe it's not production yet.
Environment plus one.
N plus one in all cases, exactly. For security, just calling out, completely multi-tenancy isn't exactly a thing right now. Use wire encryption to split your rings. The reason multi-tenancy isn't totally a thing right now is that service group keys will protect your configuration from being updated by anyone that doesn't have the matching key, but it doesn't prevent it from being read. So if you have a database password in your configuration, anyone with access to that Habitat ring will be able to read that password. So really recommend limiting the scope of your rings to a trust domain, we'll call it. So each ring should be like a dev, a QA, or a prod. The only people that have access to your prod ring are people that should, and they are all allowed to see that password, right?
So kind of the existing ways that you would think about limiting the scope of secrets today.
Yeah.
Transfers.
Exactly. So keep a supervisor ring to be a trust domain. Use that service group key to protect config updates, because there are people that you may want to be able to read or troubleshoot the config. And the other thing that using the service group key does is prevent someone from sneaking a config in. So if only the pipeline has access to that service group key, then only the pipeline can update your service group for you. And then protect sensitive endpoints with HTTP auth. I have a cheat sheet next that'll show you how to do that. So this is just a quick security cheat sheet, how to generate a ring for your Habitat ring, how to generate a service group key, how to start your ring and start your package with that key, and then also how to add a token to your supervisor gateway so that when people go and hit it, they have to authenticate. So this is just a bunch of quick cheater codes that you can use. And I'm going to pass it off to Josh now to cover some scaling stuff.
Thanks, Andrew.
Thank you.
For anyone that knows me, that's probably the longest I've ever gone without talking. So that was really hard for me. First I want to start off with where we're at today and what the current bounds of scaling is in Habitat Rings. So our current recommendation is about 200 to 300 max members in a ring. There's a little bit of fudge room there, but generally going over that leads to diminishing returns because of the profile of network connections in our gossip implementation right now. And also a big thing to consider is when you're thinking about these ring sizes, you start with a couple services and there's always another service, it seems like. As you start habitizing things on machines, there's another agent or another team that has a managed service or something that when people see the results, they want in on it. So you want to have a little bit of room to growth, and right now 200 to 300 max ring size is about where that's at. And in any gossip protocol implementation is a sliding scale in between minimizing the network traffic that's in that network versus maximizing guaranteed message delivery. And the point that we started with Habitat's gossip implementation is absolutely focusing to make sure the message is received and gets there. And we're working back to increase efficiency from there. And the roadmap of improvements are known, and we have good strategies for those. But because Habitat is such a wide encompassing solution for so many different use cases, it's going to take time to make a general tunable solution that works for everybody. Luckily, we've had several teams, including the one that I'm lucky to work on, that's invested in a lot of tooling and methodology so that we can make sure that we get it right and we have the right instrumentation. So to go back to what Andrew was saying, normally you'll have some kind of organizational constraints that lead to partitioning of your systems anyway, whether that be natural boundaries for applications and services, logical environments like dev, stage, and prod, failure domains and regional data centers. Maybe you're running a managed service or SaaS platform that needs environments split up across tenancy. Or maybe your industry requires some additional micro-segmentation or other kind of network security policies that force you to partition a little bit more aggressively. So what we're recommending with scaling right now is, as Andrew said, with several of the topologies he talked about, you always want to realize that scaling comes with a cost, and you want to weigh the costs and benefits when you're peering things, when you're peering Habitat supervisors. And two of the main reasons why you want to do that are when you have dependent Habitat services that rely on service binds for dependent configuration between the two. Let's say there's, in your three-tier architecture, you have a web front end, a front end, a web layer, and then a back end. You'll have binds between those where if, let's say, the database port were to change, you need to retrigger every service that points to the connection string for that database. Those are good reasons to peer your supervisors. Also, if you have a clustered service like an HA topology for a database or something like that that needs gossip to communicate leader election, that's another really good use case for it. If your reason why you want to peer things is for ease of use to inject configuration everywhere, I would argue that there's probably other ways to get the same result with less cost. One of the main ways that we do that is by leveraging the REST API of the supervisor. And pretty much everything that peered supervisors can discover from each other, you can discover across rings if you're coordinating the configuration credentials that are needed for those. Here's a couple of the REST API points that I use pretty much on a daily basis. The butterfly port, or the butterfly endpoint, is kind of a holy grail of a lot of useful information, and all of these endpoints return a JSON response. So you can see the first one, I piped it to JQ as a hint there. Also, you could call specific service group configuration endpoints. You can check health levels of service groups, of organization level service groups. There are a lot of different iterations of the endpoints you can hit, and they're all in that URL right there. And then additionally, another really important tuning parameter that we've come across in the field is the Hab rumor share limit. So I mentioned that delivery was an absolute imperative, it was a non-negotiable, because what good is a decentralized ring if you can't have confidence that they're going to coordinate in the ways that you're hoping for? So by default, the system will send gossip messages twice to every supervisor, even though the gossip messages are sent over TCP and there's a certain amount of reliability to that. So in practice, you can set that to 1 and cut your gossip traffic in half. And this is an undocumented feature, but eventually you won't need it because we've come to realize that we could scale back the delivery of those messages a little bit and still ensure coverage across networks in the ways that we need to. So you can set that in any time that you're starting a supervised process. If you add that rumor share limit, you can control that setting. So one of the projects that my team has been working on since the beginning of the year is a load testing framework to try to emulate some production environments of our customers that are running these habitat rings. Because what we found is that every plan is a good plan until it doesn't always survive a punch in the face. And my team specifically was tasked with bridging the gap between the real-world environments that our customers are deploying these things on with noisy neighbors, maybe over-provisioned VMs, non-pristine environments that we might have in our pipelines to test some of these load things.
Wait, Josh, are you telling us that some companies may over-provision their virtual environments?
I've heard a rumor once or twice, yeah.
Yeah? No
Yeah.
way.
So right here, what I did is I spun up this load test, and I did 3 runs of it with different ring sizes. So I scaled, this is a Kubernetes cluster where we scaled Habitat supervisors. This graph goes from 0 to 1,500 in 5-minute increments. Every 5 minutes, it spins up 250 new supervisors. And I ran 3 tests with the ring size of 100, 200, and 300. And the results that we got line up with the recommendations we've been giving of about 200 to 300 is that sweet spot. This one at 400, let me jump back. There we go. Don't touch that. So anyway, you can see here, 1 to 200, like there's not that much difference, but like jumping from 200 to 400, I don't know if you can see that scale right there, but the high peak of 400 is a load of 8 on an 8-core machine. So as you scale, like quadratically, the network profile scales quadratically right now. So this is a slide right here just to show you the CPU usage, largely in line with the load, just to demonstrate that it is largely a CPU bottleneck when you scale the supervisor rings really large. I wanted to show here, this is disk I/O. It's pretty much a non-factor, but I just wanted to prove that point, largely because the supervisors persist their rumors to disk every 30 seconds on a fixed interval, and that scales linearly just with the number of supervisors. So, that's a factor in load, and I wanted to show you the CPU and the disk just so you could see it wasn't disk. And then finally, we've done a lot of really good work from the beginning of the end of last year to the beginning of this year to improve the memory profile of the supervisors. And I only show this slide right here. It's pretty boring, just to show you that memory was not a constraint in these load tests at all. So knowing that you want to think about your supervisor rings and, pragmatically in the ways that you think about your architecture regardless of habitat, if everything is not in one giant ring, how do you have the guarantee of consistency across everything that one giant ring would give you? And that's through the remote command and control structure of the Habitat Supervisor. So as Andrew mentioned, you want to be pipelining all of your changes, and that includes not just Habitat packages, but also your configuration changes when you're delivering those. You don't want to be delivering those with a human, doing a hab config apply. You want a pipeline that's approved those changes and that's been reviewed. And so if you're delivering your configuration changes for Habitat through a pipeline, you can leverage the command and control structure of remote supervisors to coordinate the same configuration change, the same the same remote actions on n number of clusters through the same pipeline, as if it were one global one. And the way that you do that securely is by coordinating your hab-cuddle secrets that are used to authenticate with the control gateway for the Habitat supervisor. And that comes in two forms. When you're invoking the Habitat binary, so if your pipeline is running hab config apply, you would generate your cuddle secret, and you'd set that as an environment variable. For the remote supervisor, for it to have, to coordinate its cuddle secret, it has to live in a file that has to be laid down before the supervisor starts, normally by a provisioning or configuration management process, as Andrew alluded to earlier. So just a quick note about rumors. I mentioned that the number of supervisors is the largest constraint for scaling when it comes to Habitat rings. But the second factor is going to be rumors, and that comes both in rumors from the service configuration that you inject into your cluster, but also just by the number of members that are in there and then the topologies that they're managing for leader election. If you're ever curious, you can look at that butterfly endpoint, and it has top-level keys for every different type of rumor that it has. I'd encourage you guys to really check into those API endpoints, because there's a lot of useful information in there. And on that note, so the metrics endpoint that you can call from the gateway will give you every statistic you wanted and probably some that you didn't. So for the ease of putting this on slides, I grepped out anything that had to do with rumors and gossip. And these are going to be really good for understanding what I was talking about, the scaling profile of your gossip ring, and whether you're running one service or 5 services on your supervisor, it's going to affect that. And this metrics endpoint is going to be a really good place to monitor the change that has on your system. Additionally, there are some SWIM metrics, and for anybody that's not familiar with SWIM, it's a consensus protocol that Butterfly is based on for Habitat to do all of its peering and discovery. And these are just some rudimentary statistics that you can gather for SWIM to troubleshoot when maybe you have a network problem and rings are, if you have a ring that's split branding or something weird. These SWIM metrics are a really good place to look. Specifically, the ACK ping and ping requests. When things are going askew, you'll see fewer pings and more ping requests. So that's a really good thing to watch out for. But normally, if you have to look for that, you kind of already have an idea that something has gone askew. And then finally, here's a couple really useful metrics that I've seen has had success plugging into monitoring agents and having a really good smoke test for the general health of supervisor rings. It'll give you some peer health statistics, as well as some memory usage and file descriptor stats for the supervisor processes. And those are just good things to generally be aware of, because if you see a spike, something is probably wrong. And that's what we have. We wanted to leave a little bit of time at the end for questions, and we hope that you brought them. Jerry's going to be walking around with a microphone.
I have a question. Is it working? It's working.
Thank you.
It's working.
Any questions? Jerry's got a microphone there.
Yeah.
Give it to Greg. Greg always has a question.
Where's Greg?
Greg is right there. He's got his hand up. He's
Oh,
always
that
got,
Greg?
He's always got a
there we
question.
go.
Let's just go straight to him.
So you talked about using channels, and you kind of gave the very basic dev stage prod, right? But then you started talking about using canary deployments, and maybe it's not channel prod, maybe it's channel 10% prod, channel 90% prod. Is there any limitations that we should be aware about concerning channels, and like if we try to get creative with them? And I get that, right, it's artifact promotion and whatnot, and the things that pay attention to it, but just anything that you've seen that we should necessarily be aware of?
I mean, not specifically. Your cap is always going to be how much load your builder instance can take. I would avoid naming channels something funky, like having a backslash in it, or something crazy like that. But other than that, we haven't really seen a problem. It's just another API request to builder to check to see what's the most recent package on this channel that's available right now. So your limitation is mostly on the builder side there. And if you're hitting that limitation on a channel, you're going to hit it no matter what at that point. So.
Have you seen additional channels add an extra load as well, or no?
The question was, have we seen additional channels add extra load? I have not.
I haven't had that experience either.
Yeah.
Do we have any inspect profiles with the inspect 4.0 work for the smoke tests or something to like, if the metrics ever exceed this amount, send me an alert?
We don't today, but that would be a great idea.
That sounds like I was seeing that. I was like, we have a tool for that.
Yeah.
Earlier in the presentation, you'd mentioned exporting to Docker containers. I've tried that a bit, and the images that it creates are gigantic. Is there any reason for that, or how that works and why that is?
So I noticed that this week. I don't know if that's a recent regression or something that's happened in a recent build, but I noticed when I was doing some exports for these load tests that my containers were bigger than normal. I don't have a good answer for you, but it shouldn't be that way. And
Okay. I noticed it starting probably late last year. When I
well,
was doing some
that hasn't been
testing.
my experience. Well, so a lot of times, it really depends on the. So are the Docker containers disproportionately bigger than the Habitat artifacts?
Yes, significantly, like gigs. Yeah. Like one of them was 900.
We have someone trying to make a comment, so let's throw it back there.
Yeah, I mean, I don't know the definitive answer, but I think there's an open issue already for doing better efficiency with the Docker layering. That's an open issue with Hab, so I expect that would get better over time.
Yeah, I know we do start at a minimal image. Like when we build that, so you remember that your Habitat artifact, even though, so we say it includes all your dependencies and blah, 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 but it actually just includes the binaries that were needed for your application, but it also contains a metadata tree of every other package that it needs. So you might see that your heart file is a certain size and your container is much bigger than that, but it could be the dependency tree of your Habitat artifact actually is pulling in all of this other stuff that is needed, and that does get packaged into your container. So I think like Salim was saying, there is an open issue against it, it sounds like. So it sounds like it's something we're looking at. I don't have an answer for you right now.
I had a bit of a question on when you should actually use binds, because I noticed before when you were talking about the different type of rings, one of the first examples you showed is that each supervisor would be its own ring, and you mentioned the use case specifically of if you're using something else for service discovery, and you mentioned console, for example. In our experience, when we've actually used console, we've launched it with Habitat, and what we would have is other services actually binding to console. So for us, that would have to be in the same ring, and I was just wondering, would you draw a boundary there and say you shouldn't bind, and maybe you should use like DNS instead of actually using IPs through binds or things like that?
I think so the real answer to that is that it depends, and it's really going to be, are you willing to pay the cost of having a big ring, right? Are you willing, from an infrastructure perspective, to have a certain amount of memory and a certain amount of CPU consumed per supervisor to actually maintain the state of that ring? Because the Habitat ring ends up being a big state machine, right? At that point, like it's holding all the binds, it's holding all the state of the system. It becomes a state machine, and there is a cost to keeping that running. If you're staying under the 200 to 300 number that Josh has been talking about, the cost is fairly low, and I would say go for it. It's as long as you keep the other things that we talked about, like multi-tenancy and security in mind, then you should be fine, and I would keep it in a ring at that point. I love the idea of just having this easy to use kind of ring that you can consume, but as we found in practice, there's a cost to running a large ring.
And to go back to what I was saying about the cost benefit, trade-off when you're deciding whether it's worth it to peer things, it's really like what you're giving up there by not binding things is the push notification of that config change. Whereas if they're not, if there's no bind to them, then you have to pull and just, find out yourself on some kind of interval when that value has changed and then act on it.
If you want, you can yell it, I'll repeat it, or we can Well, it's going to be 2 seconds, I guess.
This goes on.
He's almost there. There we go.
So I realize that this is made for deployments on multiple types of, VMs, bare metal, and possibly containers. If in the Kubernetes world, does the supervisor have some sort of interaction with the config maps and service discovery mechanisms built into Kubernetes?
So there is a habitat operator for Kubernetes that was launched last year at ChefConf. I would say that it works for a very specific use case, and if you need it outside of that, then you're better off not managing that the Kubernetes relationship yourself. A lot of the load testing framework, well, all of the load testing framework that I had those screenshots from was implemented in Kubernetes. So myself and the person that's sitting right behind you build it in Kubernetes. So we have a lot of thoughts about Habitat in Kubernetes. And if you want to talk after, I will gladly talk to you about that over beer or tea.
All right. Oh, yeah, we'll take one more. Sure. So the question was, have we seen success with COTS applications? Honestly, in these individual supervisor ring setups, that's the main thing that gets packaged up. It's some sort of COTS agent or COTS application. There's a group of people up here at the front that are great to talk about that if you want to hit them up. And me too. Like, I'm more than willing to talk to anyone about it. But yes, off-the-shelf vendored software, taking it and putting it in a Habitat package can give you a really smooth way to actually update those things that you don't necessarily get in other ways. So, all right, thank you everyone. Appreciate your time. Hope you learned something.